In this video, we're going to talk about different ways that we can measure the location, the center of the distribution, and the variability in a distribution. For that, we're going to use data file home sales. So I have the data file here. We have the list of selling prices for 12 houses. I'm gonna start with the location measures. So we have here we have the mean or average, we have median, and we have mode. I'm not gonna talk about geometric mean for now, but let's just write down the list here. So location measures. We have location measures. We have mean, median, and mode. Okay, so mean is simply the average, and the formula for that, we're not going to talk about the formula. You're not supposed to use these mathematical formula here, but you should know the definition here. You should be able to interpret, you should be able to understand the formula. But when it comes to our course, when it comes to Excel, you just need to know the Excel function for computing it. You don't need to manually find the value of X bar here. You just need to know the average function in Excel and be able to use it for computation purposes. So it's just the sum of observations divided by the number of observations, which gives you the simple average, right? So in Excel, it's going to be, the function is going to be average of the observations. Average B2 to B13. It's going to give you the simple mean. So that's just it, and it's already been set to give you in dollar values. But if you want to change it, you can change it here. But that's fine for now. So that's mean. That's the average. Moving on to the next one. Moving on to the median. Median is the value in the middle of a data set. So for finding the median manually, you have to sort the data let's say in an ascending order, and then pick the value in the middle. And if you have an even number of observations, for example, if you have 4 observations, you have to pick the value in the middle of the 2 values in the middle. So let's say if you have 4 observations, the second one and the third one, these 2 are in the middle of the data set, basically. So you need to pick the simple average between the second and third as the median value for a data set that has 4 values in total, right? So when you have even numbers, you need to pick the average of 2 middle values. Again, when it comes to Excel, you just need to use the median function. Median of a data set, and it's going to give you exactly what you are looking for. You don't have to sort the data for median. If you're using the median function, it's going to give it. Mode, the next one. Mode is the most frequent observation. Let me just move on. Mode is the most frequent observation in a data set. For finding that, you just need to find the one or ones that appear the most, right? And if you if you know that there is only one mode, sometimes there are multiple multiple values that appear multiple times equally. So those values, in those cases, you will have multiple modes. It's always safer when it comes to Excel to just look for multiple modes, and then if you're sure that you don't have multiple modes, you can move on to the single mode function. We have two functions for finding modes, like I said, depending on if you're looking for multiple or single mode. I'm just going to go for multiple. Again, this is the second case of um, array functions that we're using. We used frequency function before. Frequency was an array function. This is another array function. So I'm going to go with 3. I'm hypothesizing. I'm imagining there can be up to 3 modes in my data set. So I select 3 cells, start typing mode dot multiple dot mult, and then data set, and then Control Shift Enter or Command Shift Enter. As you can see, it gives me 2 values, 2 different values, and an error at the end. So this will tell me that there are exactly 2 modes in this data set. So what I can do, I can just go back again, start again, Control Z, for example. I know that there are only 2 modes, so this time I select 2 cells, start typing mode.multiple, data set, Control Shift, Enter, and it gives me both modes. Again, this data file, some of the cells have predefined formats, so I'm just gonna change everything. I just used the format painter, and I just copied the format from here and pasted all the way to the end here. So we have mode 1, modes, or mode 1, mode 2, mode 2. All right. So that's it about the location. So we were looking for the center of the distribution, and these are 3 ways that give you um, 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 the answer to that question, where the majority of the observations are located. I mean, mean, median, and mode. These are, to some extent, each one of them are giving answer to that question. The second category of the measures that we're going to use, um, measures of variability. And we're going to start with the range. Range is the simplest measure of variability, and it simply takes the difference between the largest and the smallest value in a set. So range, I'm just going to find the minimum and maximum, and then range would be maximum minus minimum. So minimum would be, the function is min of a data set. Maximum would be max of a data set. And range would be max minus mean. You could use max and mean in the same cell, but I just wanted to have min and max in 2 different cells here, right? All right, so it's telling us that the difference between the smallest house, house with the smallest price and house with the largest price in this sample is almost $350,000. So that defines the range of our sample, right? That's the simplest measure of variability, and it's not perfect. It's not the best one because I mean, its advantage, which is the simplicity, its own disadvantage as well. It's because of just using two values, just the minimum and maximum. It doesn't give us a lot of information. It just tells us that this is the difference between minimum and maximum. We don't know how values are different from the center of the observation. That doesn't tell us the range. That doesn't tell us how the observations are different from the mean, from the center of the observation. So for that, we're going to use the second measure of the variability, which is variance. And here we have the variance. Variance is I'm just going to look at we have two formulas here: sample variance, population variance, and it's just the difference is caused by the denominator. Here we have n minus 1. Here we have n, capital N. I'm just going to talk about this one. It's the average of, as you can see, we take the sum and then divide it by the number of observations. That gives us the average of squared errors from, or a squared deviation from the mean of the population. So mu being the mean of the population, mu, X bar being the mean of a sample, average of a sample, average of a population, right? So deviations of observations from the mean, from the population mean, if you take this square and take the sum of all these observations divided by the number of observations, it's going to give you the population variance. Same idea, instead of population mean, you use the sample mean, and instead of dividing by n population number, you divide it by n minus 1. That would be sample variance, and it's an unbiased estimator for this one, because we're going to talk about it later in the course. Most of the time, we don't have this. We want to estimate this. In order to estimate this, we take a sample variance. Just to make the sample variance an unbiased estimator, we just need to divide it by a smaller number, right? Because if we just divide it by n, it's gonna underestimate the variance. It's gonna show a smaller value. Just to make sure that it's an unbiased estimator, we divide it by n minus 1. But that's the detail. Again, when it comes to finding these variance in Excel, we just need to use var function, var variance var dot. As you can see here, we have population and we have sample, P and S. Most of the data files that we're working on in this course, almost all of them are samples. We're always working with samples. If you know in a specific question that the data set that you have is a population, you have the full list of all the members, you go with variance dot population. Otherwise, you always go with sample. All right. And then selecting the data point, and that's going to give you the variance here. So as you can see, it's a huge number here. So it gives you the average squared error, right? Squared error, an error from the mean, squared deviation from the mean. It's hard to interpret. It's a large number. It's hard to interpret. Just to make more sense out of it, we usually go with something else that is derived directly from variance. It's just a square root of variance, and it's called standard deviation. Standard deviation. Again, since we had two formulas for variance, and standard deviation is just square root of variance, we can have two formulas in Excel. So for a standard deviation, you can take the square root of this. You can take the square root of this. You can, I mean, this is how you can take a square root, or you can use QRT function. It's going to give you the standard deviation, or you may want to use the, I would recommend this one actually, using the stdev.s. Again, stdev, finding the standard deviation. We have two functions, population and sample. We're going to use sample and data points. All right, that's going to give us the standard deviation. Standard deviation is the typical difference, typical deviation of observations from the mean, right? So that gives us a quick idea about how the data, how these data points are basically different from the mean, how they're spread around the mean. So that's the typical deviation from the mean. On average, something like that, you can say something like that. On average, each one of them are far from the mean by this much, by $95,000. All right. And again, these are dollar values again. This is not dollar value, this is dollar squared. So I'm gonna remove the dollar sign here. But standard deviation now is in dollar units. So I just add the dollar sign here. And these are fines. Yeah. Okay. All right. Next one, coefficient of variation is simply standard deviation divided by the mean. Coefficient of variation. And it's usually great when you want to compare the variability of two samples, because this will kind of normalizes the variability by dividing it by the mean. And if you want to show it in percentage, you go ahead and show it in percentage format, add some decimals. That will give you the coefficient of variation, 43%. That's just the, again, this will tell you that typically speaking, the observations are 43% deviated, different from the mean. So that's how you can interpret this number. On average, these observations are 43% far from the mean, right? That's the standard deviation, but in terms of the number of means that they're different from the mean itself.